Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Ghisam and I would like to present about my final year project topic, which is the deposition and characterization of dielectric materials. My project was supervised by Dr. Elina Dia binti Abdul Latif. My presentation content will include project summary, introduction, which will have literature review, problem statement, objective, scope and limitation of study, methodology, and expected result. For summary of this project, a research will be done to identify a suitable deposition method that will lead to the identification of the characteristic of the deposited dielectric material, and the electrowetting properties also will be observed. For introduction, dielectric material performance in electrowetting on dielectric or EWOD application depend critically on their permittivity, breakdown strength, and thermal stability among the other features. In the introduction section, we'll have literature review, problem statement, objective, and scope and limitation of the study. For literature review, the first content is about electrowetting on dielectric or EWOD for short. EWOD technology is a desirable alternative for designing and producing microfluidic system because of the low power consumption, and its driving force of the application is the surface tension which manipulate by applying the right voltage to the device. The EWOD also have an equation which predict the contact angle for an EWOD system, which is Young-Lippmann equation. The second content in the literature review is about dielectric materials, which define as the material with high electrical resistance and the capacity to hold an electrical charge so that it makes this material suitable for insulator in electrical system, which the material will prevent the flow of electricity. The third content is about the deposition method. For example, spin coating, which is the current film forming method, and the spray coating and screen printing, which are the processing-wise more desirable method. The last content in the literature review is about the characterization method, which the most film characterized relatively effective by refractive index, moisture exposure, and thermal annealing. For this project, it has a problem which the deposition uniformity to ensure the consistent properties and performance of the electric material. This project will involve three objectives, which are the preparation of dielectric sample using the deposition technique, characterizing the deposited dielectric materials such as the thickness and roughness, and an electrowetting experiment also will be conducted to measure the contact angle formed when applying some voltage. The scopes for this project are the technique of deposition method, the method to assess the dielectric material structural and electrical properties, and the technique to measuring the contact angle of water droplet on the deposited dielectric materials. This project also will have some limitations, which the study only include some method for the characterization and deposition of the electric materials. The study limit only to electrowetting on the electric application, and only limited dielectric materials will be observed in the research. For the next content is about the project methodology. The methodology was illustrated in a flowchart for better understanding of this project flow. Firstly, the project will have an initial study of some journal article to understanding about the suitable selection of the electric material for the project. The second one is justification, which will determine the appropriate deposition technique for the material chosen. For the third one is the physical development which perform the deposition technique to the selected dielectric material. Next, for experimental and analysis, we'll divide into two sections, which is the first one is an experiment will be conduct to analyze the dielectric material characteristic. And lastly, performing an experiment to observe the contact angle on the EWOD experiment that measured by a contact angle goniometer. Last section is about the expected result, which shows an example of deposited technique on different dielectric materials. The measurement used droplet to reduce gravity influences and gold wire would dip took the droplet and apply with some direct current voltage. The measurement will conduct 3 times to cancel out the effect of evaporation and build up the static electricity. Next, the graph shows that the contact angle variation of water on different dielectric materials, which are cytop, parylene, PDMS, and SAM versus the applied voltage. All trends shows that when applied some voltage, the contact angle will be decreasing. For the next graph, it shows that the influences of dielectric thickness on contact angle variation for specific electrical potential. For the trend of the graph, it shows that the higher the thickness, the higher the applied voltage. PDMS voltage is higher than cytop. The next one show the graph of the reversibility of the contact angle versus the voltage actuation. The voltage actuation can cause a water droplet contact angle to reverse on the side top layer. The histories of the contact angle range from 3.2 degrees to 4 degrees, which is suitable for AWOD device. And lastly, the other studies indicate that for voltage below 15 volt, there is an exponential relationship between the droplet velocity and the applied voltage. So this proposal refer from 11 article, and this is the project Gantt chart for my project. That's all from me. Thank you for listening.